very short tutorial on how to do linked lists. Yeah, just me kind of explaining how I go through it. Yeah, so we're going to start off with making our structure. So we're going to say struct link node. Link value, and cool, so that's our structure, and then we're going to make it referenceable. So we're going to say this means that when we reference it, we can just use this one with the capital L instead of saying struct link node and then our new link. We can just say link node new link. Cool. So let's make some new links. Okay. Well, first we have to make a head. So we're going to say create first item head, which is an empty node. And then next we're going to make create some nodes. Then we're going to add /insert new node to the list, and then we're going to delete, and then we're going to be able to print nodes. Cool, so we're going to start off with creating our first item. So we're going to say link node head equals null. Very simple. Making a node head, which is null, it's basically going to be the terminating factor of our link. Yeah, let's make our first node. Cool, we are missing a star, but yes, this is essentially how you declare a new node, a new empty, not null, empty node. Now we have to populate node 1, so we're going to say node 1 value equals 1. Okay, so just quickly, if you have a structure, like let's say you have a structure which is players, and it has player name, and it has like goals, you would usually reference, if you wanted to reference the name, you would say player.name. Here, with a pointer structure, you have to use this arrow instead of the dot. So it's just saying, essentially it's saying node 1 dot value, but because it's a pointer, you say node 1 arrow value. And then we're going to say node 1 next pointer points to head, and then we're going to just make the head equal node 1. If you include this every time, you don't lose your head, and it's always easy to ensure that you read out your list of nodes from the beginning. So I'm just going to make a couple more of these. So we'll make node 2. And here we're going to make node 2 point to node 1. And then we're going to say the head now points to node 2. So this is our list. So node 1 is pointing to node 2 is pointing to node 1, and node 1 is essentially the bottom of our list, or yeah, the bottom of our list. So we'll make one more of these. Node 3. And again, it's now pointing to node 2, right? And the head is pointing to node 3. Cool, perfect. We've made 3 nodes. We've got a head, we've got a tail, which is essentially node 1. And if you even wanted to, you could say link node tail equals null also. And then next pointer would actually point to tail. Yeah, it's doing the same thing here. With the first addition without the tail, we essentially just made a pointer null. Here we're doing exactly the same thing, making a pointer null. Perfect. So let's actually skip these two, and let's print these out. So the way we print it out is we make a temporary value. So we say link node temp equals head. We just use this so that we can change what temp is without having to worry about head. So we say while temp is not equal to null. So, i.e., when the temp is not at the tail. So, I'm going to step down this list, and we can make it stop when it reaches the tail. So when it's not at the tail, print out the value that it's pointing to. So we're going to say temp dot not dot, arrow, dot value. Yes, we're going to print that out. So we're going to say printf d dash. Cool. And then we're going to make the temp step down to the next item. So we're going to say temp equals perfect. And then once it's done all of that, then we're going to just print out a new line character so that it's easy to read. So let's see how this runs. I'm going to build and then run it. Here we go. So there's our current list, 3, 2, 1. Very simple. And yes, so the next step is we're going to insert or add a new node. So we're going to say, in the same way that we declared them earlier, we're going to say link node new node equals malloc. Cool. This statement here is basically a free mark. If you can just remember what that is, yeah, very free mark. I'm going to say link node dash, not link node, sorry, new node. Value is, say, 15. And then what we're going to do is we're going to insert this at some random point, let's say between 3 and 2. So we're going to make, our idea is that we're going to make new node point to node 2 initially, and then we're going to make node 3 point to new node. So we're inserting it kind of on the side here, and it's going to be popped right into that order. So we're going to say new node next pointer is equal to node 2, right? Yeah, and then what we're going to do is we're going to say that node 3 dash next pointer is now pointing at new node. Cool, so let's test this out. Build finish, and there you see 15, 3, 15, 2, 1. So it's been inserted right between node 3 and node 2. Our next kind of idea is this. The way that this one works is you know what node 3 is, and you know what node 2 is. Sometimes you don't know what both of them are. So you can insert in front of, you can almost never insert behind, because they only ever know what's in front of them. So here, if you wanted to, you could say, instead of saying equals to node 2, you could say node 3, and then next pointer. So it's essentially doing the same thing because node 3 was already pointing there. So node 3 was already pointing at node 2. So all you're doing is copying where it's pointing to instead of actually pointing to node 2. So if you see that runs, and it should do exactly the same thing again. There we go. So that's two of the types of inserts that they can ask you. They can ask you what current is, which would have been node 2, and they can ask you what previous is, or they can ask you both. So yeah, cool. Let's add our last one, which is delete. So deleting is quite simple, and it's quite easy to do by mistake. Essentially what you do is you do this step here, but in reverse. So you can say, let's say we want to delete node 2, right? We're going to say node 3, or in this case, our third node, which would be new node. Instead of pointing to node 2, it now points to node 1. And then now nothing in this list is pointing to node 2. And then we free node 2. So yeah, we can say, well, actually, let's say we want to delete this new node that we just added in. So now instead of saying node 3 pointing to new node, we're going to say node 3 just points to node 2. And then because the head is still pointing at node 3, nothing's pointing to new node, and therefore it's going to be deleted. So we're going to say node 3 next pointer equals node 2. So now instead, you can see here currently node 3 is pointing at new node, and now we're making node 3 point to node 2. So that's a change. And pretty much node 3 is already, new node is almost already deleted. Now all we need to do is free it. So we're going to say free node 2 with a star. Oh, not node 2, sorry, new node. Cool, and that should pass up. There we go. And there you can see that our list is back to 3, 2, 1. Yeah, so that's essentially all of what you need to know for linking nodes. I hope this video helped, and that it's not too confusing. There's definitely more efficient ways to do this, like you can make a function called create a new node, you can make a function called insert in queue, and you can make functions called delete and functions called print. But essentially, this is how it all works. Yeah, so thank you for watching, and cheers. Back, and all that I've done now is I've made some functions to do exactly what those 4 steps that we did last time. So first of all, these 2 steps you have to create by yourself. The tail isn't really that necessary, but yeah, so that has to be in main. Whereas this create some nodes, this I've created a function for, this I've created a function for. So yes, so let's look at them. So create a new node, very simple, you pass the value and it returns a node with that value. It's extremely simple. Insert after a node, it works exactly the same way that we did it earlier. You pass it, you basically say the node to insert after. So here, node to insert after points to, well, the new node points to where the current node points to, and then the current node points to this new node. The delete node is very, very similar, and print node is exactly how we did it earlier. So let's use these quickly. Let's say, well, let's actually go to the bottom. So let's say we want to create a new node. So we're going to say new node 2 equals create new node. I'm going to say 25 link node. So cool. And then we're going to want to insert it. So we're going to say insert after node. We want to insert it after node 3. And we are inserting new node 2. Cool. So if we yeah, and then we're going to go print out nodes, and we're going to give it the head. Yeah. Oh, wrong place for that. Yes, we need a semicolon on that. Okay, so let's run this. Should give us 2. Yeah, so you see that this is the original one. And if we comment out this printing and then run it again, it will just be 325 to 1. Cool, so we inserted these. If we wanted to, yeah, it's very, very simple. You can do this in a quicker way. You can say insert after node, node 2, let's say, and create a new node 50. And then we can run that, and that should be after node 2, between 2 and 1, and there we go. So that's the easiest way to use this, and these are the functions that you need to know. One small point is that this when you create a function called link node, you have to use the star, because when you return it, this is a pointer and this is a pointer too. Cool. So that's all I have to add.